In this lesson, we're going to examine some of the trigonometric ideas we learned about last year in grade 10. So we'll go through SOHCAHTOA and we'll go through cosine law. So reminders about SOHCAHTOA. SOHCAHTOA is used for right angle triangles. In a right angle triangle, we have a known angle. We always have a known angle we're going to work with. That's right here. We can label our other three sides according to it. Our hypotenuse, always across from the right angle. Across from the known angle is always the opposite. Beside the known angle is always our adjacent. And that led us to three ideas, three ratios, if you will. The sine ratio, S sine, goes with the opposite in hypotenuse. That's where SOH came from. And cos is adjacent over hypotenuse. That's ka. And tan is opposite and adjacent. That's TOA. Okay. There are three questions we can do with this. And we'll go through each of the three types just to refresh in our minds how this worked. So I want to solve a right triangle. First thing I need to do is label my sides according to the given angle. Now 36 has to be my hypotenuse. Across from the known angle is my opposite. So if I think about the word SOHCAHTOA, which one has an O and an H in it? That's sine. So the sine of the known angle, the one we use for labeling, is opposite O, then H. That's how SOHCAHTOA is spelled, O over H. To solve things, we usually cross multiply. 1 times x is x. 36 times the sine of 72 is 36 sine 72. If we put into our calculator, we should get 34.2. Now, for our purposes, we always go to 3 sig figs. Right? So don't worry about how many decimals you need. It's about 3 sig figs. So in this case, 34.2 is correct. Okay, let's try the next one. Again, we want to label it. So I've got a hypotenuse. I've got a known angle. This side by side would be my adjacent. An A and an H. Well, that's a cos question. So the cos of our known angle equals A, 48 over H. This looks similar to the last question in that the x is in the fraction, but it's in a different spot. So we have to do it slightly different. We're still going to cross multiply. So we'll get x cos 40 equals 48. But I want to get x by itself. I want to solve for x. So I have to take 48 and divide it by our cos 40. And if I do that with my calculator, I end up with 62.7. Again, 3 sig figs. And then the third one, again labeling my sides, I've got a hypotenuse. I've got an adjacent, the cos question again. The cos of our angle, there's my x, adjacent over hypotenuse. The only spot I can put the x, in this case, was the angle. So here's our three big problems, okay? X on the top, x on the bottom, and x as the angle. So only things you can do with SOHCAHTOA. If I'm solving for an angle, I have to use an inverse function. That's the second function of the shift function in your calculator. So I'm going to take the inverse of whatever 12 over 24 is. I think it's handy to use the brackets, especially with ones that are not very nice. This one is nice, right? 12 divided by 24 is just 0.5. But if it was a big, long, never-ending decimal, use the brackets to make your life easier. And we get 60. Here are three different SOHCAHTOA kind of questions. Okay, some applications of trigonometry. Words we often come across are elevation and depression. Okay, we might remember things like we standing on the roof of a building and looking at another building. Angle of elevation, angle of depression. Okay. The key with elevation depression is they're always being measured from a horizontal line. If we were to stand on top of a roof and look straight off that roof, our angle is 0. But if I were to look up from that, I'd have an angle of elevation. If I were to look down from that, I'd have an angle of depression. It's always in relation to the horizontal. That's our key thing. These two things are always related. If you were standing on the roof, this is you standing right here, and look down at your friend who's standing on the ground, your angle of elevation from the ground up is the same as their angle of depression from the roof down because of the Z pattern. Okay, so it's all point of view. We'll try some of these things. Ingrid. She measures the angle of elevation from a point on level ground to the top of a building 120 meters high to be 32 degrees. So let's draw that. She's on level ground. She's looking up at the top of a building. The building's 120 meters tall. Her angle of elevation, horizontal up, is 32. She walks towards the building until the angle of elevation is 45. So she's here now. She looks up. Angle of elevation is now 45. How far did she walk? So if we go back to the very first problem, before we drew her walking back in, we had this triangle. A nice right angle triangle. We could figure out how far she is from the building. I can do that SOHCAHTOA. Have an opposite, have an adjacent. That's a tan question. So tan 32 equals 120 over y. We cross multiply. Y tan 32 is 120. So y is 120 over tan 32. If I put that in my calculator, I got 192 meters. That's how far she was initially. If I look at what happened next, she's now standing this far from the building. Well, that's a second right angle triangle right here, right? The small one. So if I do tan again, the tan of 45 equals 120 over z, which is the exact same math, just a different angle. I get how far she is from the building now. It turns out that's 120 meters. If you're smart, you may recognize that's an isosceles triangle, the red one. A 90, a 45, and another 45. So how far did she walk? Well, she was 192 meters away. Now she's 120 meters away. So the difference between those is 72 meters. And it's a nice application of SOHCAHTOA. Not all questions are right angled, however. So the cosine law. This is one of our handy tools for non-right angle triangles. We can use this if we know all three sides, but no angles, or we know two sides and the contained angle. And by that I might mean I have this side and this side known. Let's say this was 10 and 12, and the angle contained between them was 72. That would be a contained angle. Well, this is a sine law question, or sorry, a cosine law question. In the cosine law, the things that were important were the a values. So, some reminders. When we label a triangle, big letters are angles, small letters are corresponding opposite sides. In the cosine law, the key ones are these two, because they have to be across from each other, and you have to know one of the two and be trying to find the other one. So either you're looking for the small a because you know the big A, or you're looking for the big A because you know the small a. So if we set up some of these, there's only two questions you can really do with the cosine law. We start by labeling our a's. I'm looking for x, it's a small a. This must be the big A over here then. B and C are interchangeable. We don't care which one's which. So our equation was a squared equals b squared plus c squared minus 2bc cos a. If we fill in the parts and pieces, we've got 25 squared plus 32 squared minus 2 times 25 times 32 times the cos of our angle. We'll put it all into our calculator. We got 263.359 ... But that's x squared, right? We want x. So we need to take the square root. The square root to 3 sig figs is 16.2. Okay, so that's one of our problems we can do with the cosine law, a missing side. The other one is a missing angle. Now, it's totally fine. Okay, let's label our sides actually before we start. We're trying to find x here, so that's going to be our big A and little a, B and C. It would be totally fine to do 65 squared equals 72 squared plus 80 squared minus 2 times 72 times 80 times the cos of our angle, and have to rearrange and solve for x. But we talked last year about there being a handy rearrangement. Okay. If we're looking for an unknown angle, rather than rearranging every time while we're solving, let's rearrange the equation first. So the same equation, just with the angle part solved for. So when I go to solve this question, I can say the cos of x equals b squared plus c squared minus a squared. Now notice that a and a are still at the ends, okay? They're across from each other. They have to be to solve this property. Okay, 2 times b times c. Now I'm looking for an angle, so I'm going to have to do an inverse. To do an inverse, we like to have that fraction. So we're going to do each part separately. We're going to figure out the top number. We're going to figure out the bottom number. Make our life easier. Okay? So on the top, I got 4,225. On the bottom, I got, oops, that's not right, 72 times 80. I got 11,520. So if I want to get x, I'm going to take the inverse of whatever that comes out to. Now, I don't really care what it comes out to. I can use my brackets on my calculator and plug it all in, and I got 50.3 degrees. Okay. These are the only two questions we can do with the cosine law. Finding a missing side, which is nice. It's already all rearranged for us, all into our calculator, square root, or finding a missing angle. We're going to use our inverse, so we use the fraction. Okay, we're going to try a couple. Where we already use these as bearings. Remember some about bearings. A sailboat travels 9.2 kilometers on a bearing of 147. Oh, bearings. Hopefully you guys remember something about bearings. North, east, south, and west. Or 0, 90, 180, 270. So when we're talking about a sailboat traveling on a bearing of 147, we need ourselves a compass. The bearing always starts from 0 and it goes clockwise around. So a bearing of 147, I'm just going to make this pen a little smaller here, would go somewhere down here, okay, where the angle across the top is 147. Or in other words, 90 in the top and 57 down below. Okay. It went 9.2 kilometers and then changed directions. Anytime something changes directions, we need a new compass. So we're going to put a compass on the end here. Our boat's now going to travel 5.1 kilometers on a bearing of 265. So 265 is not quite 270, it's just below 270, so it's going to be like this. So that's 207, oh, not 70, 265. Right there. 265. And it's going to go 5.1 kilometers. And we want to know how far is the sailboat from a starting point. So really, we want to know this. Now this looks like a great cosine law question. We've got two sides. If I could figure out the angle between the two known sides, I can use the cosine law really quick. And I can find out the angle between the two sides by using a little bit of common sense here. Okay. Whenever we have two compasses, we have a z. So we set up here the angle is 57, which makes this 57. We also said this green angle was 265. It's just short of 270. How much short of 270? 5. Which, when we combine them together, gives us an angle of 62 degrees. 57 plus 5. Now, we have a cosine law question. We have big A, the angle we know, small a, the side we want to find. We have B and C, the other two sides. So using the cosine law, x squared equals b squared plus c squared minus 2 times b times c times the cos of the angle between them. And the key there was we had to use the z pattern to find the angle between them. And if we put that on our calculator, we get 66.594 dot dot dot, just to make sure on the right track. Make sure we square root it, because we want x, and we should get 8.16 kilometers. A nice use of the cosine law. All right, last one. We talked three-dimensional stuff last year, so how can we apply this stuff in 3 dimensions? A square-based right pyramid has a side length of 50. Okay, so giving us a pyramid draw our pyramid here. Pyramid. They're telling us our side length is 50, and it's a square base, so it's 50 by 50. It's got a vertical height, that's right down the middle, of 7 meters. Can we find the measure of the angle between opposite slanting sides? So if we take let's take a cross section of this, if you will. If I were to go from here up to the point and then back down the other side, I'd get a cross section right through that pyramid. It'd look kind of like this. I know it's 50 across the middle. I know it's 7 down here. And I really want to figure out the angle up here. Can we do that? Well, if I went down the middle, these are both equal. In other words, they're both 25s. And these angles are both the same. So if I can figure out one of them, I can double it and get the angle between them, right? So let's take a look at that picture for a second. If I just go to one side, I've got an x, a 7, a 25. And this is right angles. Well, that goes back to SOHCAHTOA where we started today. Opposite, adjacent, tan x, 25 over 7. Inverse question because I am missing my angle. Into my calculator I go, and I get 74.357. Okay, so the whole angle is going to be 2 of those. In other words, 2 times 74.357, and that gives us approximately 148.71, or if I go to 3 sig figs, 149 degrees. Okay, so some reminders. SOHCAHTOA, cosine law. How to find different things with them. There's only really 5 problems we can do. Often the hardest part is drawing the picture. But if we have the picture, the math is usually not too bad. Some questions to try for review. And then we're going to talk about the sine law tomorrow. I'm going to add some new things to the sine law. So that'll be slightly more challenging than this review stuff.